Have you ever stopped to wonder how your computer, just one PC on a network with maybe thousands of others, finds the exact server it needs to log you in? Well, it's not magic. It's actually a kind of secret GPS hidden inside every Windows network, and today we're going to give you the map. So let's really think about the problem here. You hit Control-Alt-Delete, you type in your password, and boom, in just a few seconds, you're looking at your desktop. But what just happened? How did your PC find the right domain controller out of maybe hundreds or even thousands of machines? It's a classic needle in a haystack situation. I mean, just imagine being dropped into a huge city with absolutely no street signs, no building numbers, and being told, go find this one specific office. That's pretty much the challenge your computer faces every single time it needs to find a network service. Without a map, it would just be, well, hopelessly lost. So our story really begins right here, with this lost client. It's just a single computer trying to find its way through the sprawling digital city, and it needs directions, like right now. And this is where the genius of the system really kicks in. Instead of just letting every computer wander around aimlessly, Windows networks have this incredibly smart built-in GPS that gives precise, almost turn-by-turn directions to any service a computer could ever need. And that GPS? It's called an SRV record, which stands for Service Record. You could think of it as the network's official, always up-to-date address book. Its job is really simple. It connects a generic service you're looking for, like authentication, to the specific server that's actually providing it. Okay, so let's take a closer look at this directory. How does it actually work, and why is it so absolutely critical for keeping a network running smoothly? So here's the most important part. SRV records mean we don't have to manually tell every single computer where the login server is, right? Instead of some static, hard-coded address that would break the second that server's name changed, the client just asks, hey, who's handling logins today? And the SRV record, kind of like a dynamic yellow pages, just gives it the most current answer. Now, any good map has its key landmarks, the capital city, the major airports, that sort of thing. So, what are the most critical destinations that every single computer on a Windows network needs to know how to find? Let's zoom in a little bit and actually learn how to read the 3 most important entries in this service directory. Because if you understand these, you're a long way towards understanding how Active Directory really works under the hood. Let's break this down with a simple office building analogy. First up, LDAP. That's like the main reception desk. It's where you go for general information and to prove who you are. Then you've got Kerberos. Think of that as the high security office that issues you your special access badge for the day. And finally, there's the Global Catalog, or GC. That's the huge directory in the lobby that can find anyone or anything across the entire corporate campus, not just in this one building. And hey, if you ever want to see these records for yourself, they're not some big secret. You can find all of these crucial NAP coordinates filed away really neatly under a special folder or a zone called MSDCS, right inside your main DNS server. Okay, this all sounds great, but who keeps this map updated? I mean, a GPS is totally useless if it's sending you to buildings that were torn down a year ago. And this brings us to what is, honestly, the most elegant part of this whole system. This right here, this quote just perfectly captures the whole philosophy. The system is designed from the ground up to be self-healing and self-updating. There's no person manually redrawing the CityMac every time a new server comes online. It just happens automatically. So how does this magic actually work? Well, it's this really cool 4-step process. When a domain controller boots up, a special service called NetLogon wakes up and it takes inventory of itself. It sees its hosting, say, the reception desk and the security office. It then securely calls up the main DNS server and basically says, hey, it's me, just letting you know I'm the one handling LDAP and Kerberos for this part of the network now. And just like that, the map is updated in real time. It's beautiful. So, knowing how the GPS is supposed to work is one thing, but what happens when it starts giving out bad directions? Let's talk about how you can actually check the map, especially when things start to go wrong. This is such a critical question for any network administrator, right? If your users start complaining that they can't log in, probably the very first place you should be looking is this service directory. Is the map correct? Are the directions it's giving out still valid? You've basically got 2 main tools for this. The DNS Management Console, that's your visual check. It's like opening up a map app on your phone just to see if the address is there. It's quick, it's easy, and it's great for a fast confirmation. But for the experts check, you're going to use a command line tool like NetDiag. This doesn't just check if the address is on the map. It runs a full diagnostic on the entire navigation system to make sure everything's working properly. So, if you're going to remember just a few things from all this, what should they be? Well, first, SRV records are the network's secret GPS. Second, those key destinations are the reception desk, which is LDAP, and the security office, which is Kerberos. And finally, the real magic is that the NetLogOn service acts like an automatic map maker, making sure the directions are always, always correct. And that really brings us to the final thought here. This whole system is designed to run silently and perfectly in the background. But when it fails, the entire network can grind to a halt. So the real question is, now that you know this map exists, are you prepared to actually read it when you're the one who's lost?